and I can't perform the sport itself because I have a broken finger. So let's go. Hi, I'm Aska, and today I'll be explaining about physics behind softball. And I was watching the game of softball between Lakeview and McCray yesterday, and I managed to get the footage, but it got deleted. I believe the part of the The ball rotates as it travels through the air. Due to the seams, there is air resistance caused by the seams. As the ball is traveling through the air, it is creating high and low pressure fronts. Motion of a ball. The grip determines the rotation of the ball. Newton's first law states that an object will remain in rest or in uniform motion unless acted upon by a force. Newton's first law is evidenced constantly in softball. When you pick up a stationary ball and throw it, changing its motion with a force, or when a ball's direction initially dictated by the throw from the pitcher. Newton's second law states that if the momentum of an object changes, if it accelerates, then there must be a resultant force acting on it. Normally, the mass of the object is constant, and the force is proportional to the acceleration of the object. The direction of the acceleration is the same as the direction of the force. When the pitcher throws the ball, it travels in the direction of the release point. The ball continues on the path until the batter hits the ball, changing its direction and speed. A good example of Newton's second law is in the high arc of a slow softball pitch. When the ball leaves the pitcher's hand, the greatest force acting on it is the player pushing and throwing the ball into the air. As soon as the ball is airborne, it comes under constant force that gradually overcomes the initial force of the player's arm. Air resistance slows the ball down and gravity begins to pull the ball towards the earth. The transfer of this force onto the ball results in the arcing motion of a slow-pitch ball. When the ball reaches the bat, the force of the bat becomes the largest force and dictates the ball's new motion out into the field. Newton's third law states that for every action there is an equal and opposite reaction. One example of Newton's third law is when you catch a ball. As the ball enters your glove and contacts the leather, it stops. In that instant, your hand exhibits a force equal to that which the ball imparts on the glove. The force you exhibit is equal and opposite to the motion of the ball. The result is that the ball stops. Counting an average speed of a player. An average speed can be calculated by dividing distance and time. Average speed can be used to find a player's average speed of multiple actions, such as throwing, running, sliding, pitching, and etc.